Customer sent in this Hertz HCP5D amplifier that stopped working after he had some welding done to his car. This is a 5-channel amplifier that uses discrete components for the subwoofer channel and these TDA integrated amplifier ICs for the front and rears. The amplifier powers up just fine with PWM on the power supply FETs looking good. Probing the Class D subwoofer channel low side MOSFET, we can see we have good oscillation. However, when we probe any of the outputs from these TDA chips, there's no oscillation whatsoever. Now these chips are quite delicate, so naturally the first thing to try is to replace them, which I did, and it made no difference. So next thing is to confirm all the supply voltages are present for these, which I did, and it looks like this, all good. Next thing is to check this chip is being told to operate, so let's have a look at what's on pin 6 mode. The datasheet tells us that with 0 volts it's in standby mode, between 2.2 volts and 3 volts it should be in muting mode, and above 4.2 volts it should be operating. And I get 6.7 volts. Now we should see if the chip's in protection mode for some reason. We've got diagnosis pin 1, 2 and a protection pin here. Here's a table of the different protection modes and when these pins will be active or not. And after checking them, nope, none of them are active. So the chips are brand new, healthy, active, not in protection mode, but not oscillating. What's the problem here? I was looking at what sets the switching frequency on these and turns out it needs a resistance between OSC and OSC ref in order to use the internal oscillator. Or when 2 chips are used, in order to synchronize the frequency, you can connect an external clock to the OSC pin as dictated here. The 2 OSC pins are actually connected together, meaning that there must be an external clock source somewhere. That means we should see a clock frequency on this pin. So the reason these chips are inactive is because there's no external clock frequency and the resistance between OSC and OSC ref is beyond 40 kilo ohms. It's just completely open, so there's no switching frequency here. So let's look for some components that will be generating external clock frequency. Crystal oscillator, binary ripple counter, that's it. Probing around here and we get absolutely nothing on the oscilloscope, no clock frequency, so this circuit here is the issue. These crystal oscillators are quite delicate and they're also connected to ground. Now remember the customer had some welding done to his vehicle which also connects to the chassis ground. I reckon some spikes have been sent up through the ground path and killed this oscillator. Let's get you out of here. And Mr. Replacement one can go in there. Now let's check the oscillator pin. Oh, this is promising. Last thing we need then is oscillation on the output. Hey!